Hello and welcome. Here we have a centrifugal pump problem and let's solve it. It says a centrifugal pump. Let me select the pen. It says a centrifugal pump runs at a tip speed of 12 meters per second and a flow velocity of 1.5 meter per second. So this is U2. This is the impeller tip velocity or U2, and this is the flow velocity. The impeller diameter is 1.2 meter and delivers 3.8 meter cube per minute. This is the flow rate. This is flow rate. The outlet plate angle is 28 degree. This is beta 2 to the tangent at the impeller periphery. Assuming that the fluid enters in the axial direction and zero slip, calculate the torque delivered by the impeller. So directly we can say that power is equal with torque multiplied by the angular velocity, and from this we can calculate the torque to be power divided by the angular velocity. Angular velocity is simply from the relation U is equals to omega times R. Let's say this is U2 and this is R2. From this we can say that omega is U2 over R2, right? And once we say this, we can also calculate the power. Now we can calculate the power. Power from the water horsepower, since we have the flow rate, we can have the water horsepower as density, gravity, the flow rate multiplied by the height. Using this, we can calculate the power. We have the density of water, we know gravity, we have the flow rate, but we don't have this head. So we are going to calculate the head from head can be calculated from the specific work as U2 CW2 minus U1 CW1 over G. This is the equation I used to calculate the head. Since we have completely we have axial inlet or radial, so we don't have the tangential or the whirl component, so we eliminate this and the head remains U2 CW2 over G. We get the head using this equation, but we don't now we don't have CW2. We have to calculate CW2 also from the velocity triangle. It was given by U2 minus C R2, the radial flow at the exit, multiplied by the quote of the beta 2, the blade angle at exit. We can calculate this, and simply if we multiply this, it becomes the specific work. Maybe we need to multiply it both sides, and if we divide this by G, it becomes simply the head. This becomes the head. Okay, so we have everything. We have U2, we have CR2, which is the flow velocity radially at the exit, 1.5 meter per second. We have also beta 2, 28. and we know the G. Now we have the H. Once we have H, we can calculate the power. So using density, gravity, flow rate multiplied by H, we have the power to be 6.98 kilowatt. So if we now know the power, and we have also the angular velocity from the rotor and from the diameter, we can say that torque is power divided by the angular velocity. So this is the power. Okay. Simply power divided by U2 over R2 will give us this 349 meter. So this is the interesting question, and it relates the blade angles, I mean the velocity triangles, with the power that can be developed from the horse power, the water horsepower, the heat. So the specific work, these things are correlated by this problem. Thank you. This is it.